Hello, students. I wanted to do a couple exact differential equation examples. It feels like magic when you do it at first, but really the whole idea is that you're trying to create a product rule on the left side of the differential equation. So I'll just take, let's do problems D and problem D and E here. So if I look at problem D, I have y prime plus y equals sine of e to the x. This is in standard form because I have standard form the derivative, then you have a function of x touching y, and then a function of x on the right side. You might not see the function of x, but you can remember this is 1y. That's kind of a function of x. You multiply by the integrating factor, which is e to the integral of the function of x dx. The integral, the antiderivative of 1 is just x. You can leave off the plus c when you do the integrating factor. You're going to multiply everything by e to the x. So I have e to the x times y prime plus e to the x times y. Don't forget to include the right side of the equation when you multiply. You got to multiply all the terms. Then you need to recognize that the left side is a product rule, and the two terms within the product are e to the x and y. And so if you take, the product rule, you do the derivative of the first times the second plus the original first times the derivative of the second. And you can see that is what we just had. So now we know that the derivative is equal to e to the x times sine of e to the x. And so we just integrate both sides. If we integrate the left side, the integral cancels the derivative. That's the fundamental theorem of calculus. So you have e to the x times y equals over here. You have something that looks kind of nasty. And for a split second, I thought it was going to be integration by parts, but you could do a u substitution here, where if u is equal to e to the x, then du is equal to e to the x dx. So it takes care of that extra e to the x in front of the sine. And so the antiderivative of sine becomes negative cosine. So negative cosine of e to the x. You should just double check if you do that derivative, do you get back to the line on top of it? And yeah. So then put a plus c on the end of that thing and then divide by e to the x, and you have got your general solution. So y is equal to negative cosine e to the x plus c divided by e to the x. And that is problem D. So I think the other one that I wanted to talk about was problem F. So let's clear the screen here and talk about problem F. Switch colors for fun. So problem F says we're doing x squared y prime plus 2xy equals cosine x. This is not in standard form. This is not in standard form here. Let me pause for 1 second. Okay, sorry about the interruption. So here we've got this in differential equation, and it is not in standard form because there's something attached to the y prime. So my first idea is divide everything by x squared, leaving me with y prime plus 2 over xy equals cosine x divided by x squared. And then what you can do is multiply by the integrating factor. And so the integrating factor is going to be e to the antiderivative of 2 over x dx, which is e to the 2 natural log of x, which nicely reduces down to x squared. And that's really nice because multiplying by x squared is going to clean up the right-hand side of the differential equation. So let's multiply everything by x squared. And we ironically get back to the beginning. X squared y prime plus 2xy equals cosine x. So that was sort of a useless thing that we did, but I wanted to put it into the standard form, multiply by the integrating factor. Turns out we get back to the original problem. And what we could have recognized at the beginning is that the left-hand side is the product rule. And the left-hand side is the product rule of x squared times y. So now we integrate both sides. Let's slide it over here. Move my face over there. So the antiderivative of the left side becomes x squared y, and the antiderivative of the right side becomes sine of x. Yep, sine of x plus c. So your y value is sine of x plus c divided by x squared. So I want to point out that we could have recognized at the beginning that there was a product rule on the left side, but if you wanted to follow through the exact differential equation idea where you multiply by the integrating factor, you get there anyway, just in this kind of weird circuitous route. So thanks for watching, and let me know if you want any more examples.